wanted to talk with you about something called Thigmotaxis. Now, Thigmotaxis is a big scientific word, but what it essentially means is an over-reliance on external cues. And I use the example of a animal research study where they were working with rats, and there's this paradigm that they have, there's a water maze involved, and so the rats can pick up on cues from the environment to where they can swim up onto a platform. So what they did was they took some of the rats and they damaged part of their brain, and it was the middle part of the frontal lobe. And what they found was that these rats would figure out where the platform was, but while they were swimming around waiting to figure it out, they would stick to the sides of the walls of the water barrel or whatever they were in. And so they figured it out in the same amount of time, so they still could process those visual cues, but they were relying on something kind of outside themselves, I guess, to keep them centered. In autism, you can think about Thigmotaxis. Probably the biggest one is that when a child goes over and pulls somebody's hand to something he wants to do, he doesn't necessarily know how to unscrew a cap or open a jar of peanut butter or whatever, and so he'll go get you to do it. And so he's relying on that. There's another study similar there's another autism study that has looked at where, they were looking at where kids were in a waiting room area, and their parents were there, and in that waiting room area, the kids were around, tended to hang out along the walls. So to summarize, children with autism are thigmotaxic. That is, they are over-reliant on external cues rather than thinking top-down, from a top-down perspective, or the cognitive motor system. An example might be that a child insists on opening and closing doors or turning a light switch on and off. They see the external object, they know what the object does, and they have a hard time inhibiting the action associated with it. For you and I, we may see the light switch and certainly know its function, but we can control not turning it on or off because we have an efficiently connected front part of our brain.